We now discuss the solution of a problem from the section Linear Algebra. The problem is based on the concept of row sum and column sum of matrices. This question has appeared in CSIR National Eligibility Test held on 16th February 2022, and this question is from the section B. The problem is, let A and B be n by n matrices. Suppose the sum of the elements in any row of A is 2 and the sum of the elements in any column of B is 2. Which of the following matrices is necessarily singular? We are given 4 options. Option 1, I minus 1 by 2 times BA transpose. Option 2, I minus 1 by 2 times AB. Option 3, I minus 1 by 4 times AB. Option 4, I minus 1 by 4 times BA transpose. We have 2 matrices A and B of order n, and it is given the sum of the elements in any row of A is 2, that is the row sum of A is 2 and the column sum of B is 2. Then which of the following is singular? And we are given 4 options. We now discuss the solution of the problem in detail, and we will now test for the case n is equal to 2, that means A and B are matrices of order 2, and we have taken particular cases A and B, and A is equal to the first row 0 to 1 1. So the row sum, the first row sum is 2, the second row sum is 2, and B is 0 1 to 1. The first column sum is 2, the second column sum is 2. So we note that the row sum of each row of capital A is 2 and the column sum of each column of B is 2. Now we have taken the product AB, A, B multiplied. So first row, first column 4, second row, first column 2, first row, second column 2, second row, second column 2. So the multiplication is done, and now we go for the option 2. I minus 1 by 2 times AB. I is 1001 minus 1 by 2 times of AB is 2111. When subtracted, you will get minus 1, minus 1, minus 1, 0. And it is non-singular because its determinant is minus 1. So look at our options. Which of the following matrices is necessarily singular? So the option 2, I minus 1 by 2 AB is non-singular. We have to find the singular matrix, singular case in this. So therefore the option 2 is eliminated. So this is eliminated by means of this counter example. And option 3, I minus 1/4 AB. So I is here, minus 1/4 of this AB is this matrix, and when subtracted you will get 0, minus 1 by 2, minus 1 by 2, 1 by 2. It is non-singular. Why? Because its determinant is minus 4. So look at the options. So this option 3 is non-singular. Therefore the option 3 is eliminated. We continue in the next slide. We have those 2 matrices for the case n is equal to 2, A and B, and now BA transpose. So this is B, A transpose. We have taken A and transposed it. When transposed, you will get 0, 1, 2, 1. When multiplied, you will get 2, 1, 2, 3. So look at the option 1. I minus 1 by 2 times BA transpose. I is this, minus 1 by 2 times BA transpose is 1 half 1 3 by 2. And when subtracted, you get this matrix, and this is I minus 1 by 2 times BA transpose, and it is non-singular because its determinant is minus 1 by 2. So our option 1 is also non-singular, therefore the option 1 is eliminated. And because this is the question that is given under section B, only one answer is correct, and we have already eliminated the options 1, 2, 3. Therefore, our answer is option 4. But anyway, we see for this case, I minus 1/4 BA transpose. When you write I is this, minus 1/4 BA transpose. 1/4 of BA transpose is this, yes, correct. And when subtracted, we get 1 by 2 minus 1 by 4 minus 1 by 2 1 by 4, and it is singular. It is singular. So this is 1 by 8 minus 1 by 8. The determinant is 1 by 8 minus 1 by 8, that is 0. It is singular. So it works out in this case for these two examples in the case of n is equal to 2. But anyway, we have concluded option 4 is the one which is singular by elimination, and by elimination the option 4 is singular. Therefore, our answer is option 4. So that's the discussion, and that's the answer of this question. But however, I want to give you a proof to say that I minus 1/4 BA transpose is singular when A and B are 2 by 2 matrices. So for n is equal to 2, I will show you this is true. For general case, for any n can also be shown similarly, and that the general case I will deal in a separate video. So we now go for the next slide to see I minus 1/4 BA transpose is singular when A and B are 2 by 2 matrices, general matrices. So what's our result? Our result is this. Let A and B be 2 by 2 matrices. If the sum of the elements in any row of A is 2 and the sum of the elements in any column of B is 2, then the first conclusion is the sum of the elements in any column of BA transpose is 4. That is, the column sum of BA transpose is 4. And the second one is I minus 1/4 BA transpose is singular. Agreed. So the proof is, let A is Aij 2 by 2. This is the matrix. B is equal to Bij 2 by 2. This is the matrix. And given the sum of the elements in any row of A is 2, that is A11 plus A12 is 2. A21 plus A22 is 2. And the sum of the elements in any column of B is 2. So B11 plus B21 is 2. B12 plus B22 is 2. So that is the hypothesis what we have, and from this I have to prove these two results. We continue in the next slide. So that is what we have. And now BA transpose, B is the matrix here, and A transpose is A11, A21. The first row is written as first column, second row is written as the second column. multiply. In a usual way, we multiply. So the multiplication is done here. So first row, first column, this element. Second row, first column, this element. And the first row, second column, this element. And the second row, second column is this element. Now, the sum of the elements in the first column of BA transpose. That means this is the first column. The sum of the elements in the first column, this is the one. So that is B11A11 plus B12A12 plus B21A11 plus B22A12. This is what we have written here. And A11 is common from the first term and the third term. And we have taken out B11 plus B21 in brackets multiplied by A11. And then from the second and the fourth terms, we get A12 common. That is B12 plus B22 times A12. And we know B11 plus B21 is what? The first column. The first column. The first column sum is 2. And B12, B22, the second column sum is 2. So that is 2 times A11 plus 2 times A12. Take 2 common. A1, it is A11 plus A12. So A11 plus A12, the first column, the first row sum is 2. So 2 into 2 is 4. So, and in a similar manner, the sum of the elements in the second column are taken, and you do it and you will get 4 again. Thus, the sum of the elements in every column of BA transpose is 4. This proves our first result, what we have stated in our theorem. Now, BA transpose has an eigenvalue 4. Why? BA, the column sum of BA transpose, the column sum of every column of BA transpose is 4, and we have a result. It says that BA transpose has an eigenvalue 4. Then 1/4 of BA transpose has an eigenvalue of 1. 1 by 4 times of 4, that is 1. And I minus 1 by 4 times of BA transpose has an eigenvalue 1 minus 1, that is equal to 0. When 0 is an eigenvalue of I minus 1 by 4 times BA transpose, then it is singular. That is I minus 1 by 4 times of BA transpose is singular. This is the second conclusion in our result. Thus we have proved that one. So hence the result. So that means if the row sum is 2 and column sum is 2, then the column sum of BA transpose is 4, and BA transpose will have an eigenvalue 4, and 1/4 of BA transpose has an eigenvalue 1. I minus 1/4 of BA transpose has an eigenvalue of 1 minus 1 is equal to 0. 0 is an eigenvalue, means it is a singular matrix. I minus 1/4 BA transpose is singular. Thus this proves the second conclusion. So hence the result. And in a similar manner, for the general case of for any n, we can prove it, and that we will prove in another video in the due course. So that is the discussion of the solution of the problem from the section linear algebra based on the row sum and column sum of matrices. I hope that you have understood the solution of this problem and concentrate on linear algebra, and many questions of this type we have seen in the past also. So concentrate on linear algebra. I wish you all the best. Thank you.